Hello people, so today we'll be solving LeetCode daily question, that is 432, all O1 data structure, and in this we have to design a data structure to store the strings count with the ability to return the strings with minimum and maximum counts. And we have to implement an all1 class, and all1 class initializes the object of the data structure, and then we have to there are four functions. Basically increase, basically in this we'll be having a parameter as a string key, and we have to increment the count of that particular string by 1. And if key does not exist in the data structure, we have to insert it with the count 1. Decrease, in this case we have to decrease by 0, and if the count of key reaches 0 after the decrement, we have to remove it from the data structure. Okay, and it is guaranteed that key exists in the data structure before the decrement. Okay, then get max key, we have to return the string which is having the maximum count, and we have to then it's the get min key. In this we have to return one of the keys with the minimum count. Okay, and we need to write the algorithm that runs an over one average time. This gives us a huge hint that we have to use like a combination of hash map and hash sets, basically maps and sets, not particularly hash map. Okay, so for this what we'll have to do is, firstly we can create a map to store the string and its particular count, and then we can have a tree set with of integer and a set of strings, and for that particular count we can store that how many strings are present, because in that case only the retrieval will be of over 1. You can also store integer with a list of strings, that will also work, but the function will not run in over 1 average time. Okay, so let's write the function. Firstly, let's have a map of string comma integer. Let's call it map that is equal to I'll initialize it later only. Let's have a tree set, oh sorry, tree map of integer comma set of string, and let's call it sorted map. And now let's initialize each of them. The map is equal to new hash map, and sorted map is equal to a new tree map. Okay, now we need to write the key increment function. So first let's have the frequency originally, so that will be equal to map dot get or default, because there is a chance that the key is not even present. Map dot get or default key comma 0. ah, okay, yeah. Now what I'll have to do is I'll be updating it into the map. So I'll be doing a map dot put key comma frequency plus 1, and then I'll have to check that if the frequency of the key is already, basically it means that it already exists. So if frequency is greater than 0, now in this case what I'll have to do is I'll have to update in the tree map, because now it's like the frequency of a particular string gets incremented, so its position will be, relative position basically will be changed. That it the let's say initially it was mapped to a 2 comma and the key, basically it that represents that 2 was the count of that particular string, but now it has been incremented, and now the frequency has changed to 3. So we need to update a sorted map as well. Okay, so here it will be only applicable that if frequency is greater than 0, not equal to 0. Okay, uh, yeah, because this time the key is not even present in sorted map. Okay, so if frequency is greater than 0, what I'll have to do is I'll do a sorted map dot get the element which is present at the particular frequency, and I'll be removing the current key from it. Dot remove key, and then what I'll be doing is I'll be checking that if sorted map dot get count dot is empty, basically it means that there is no more strings associated with that particular frequency. Dot get frequency, then I have to remove it from the map. So sorted map dot remove the frequency, and after that I'll be updating my sorted map as well. Okay, so what I'll be doing is I'll be doing a sorted map dot put my to frequency plus 1, basically the incremental frequency plus 1 comma new hash set, okay, new hash set, and in this I'll be adding dot dot add the particular key. Okay, and now let's have the decrement function as well. So firstly, if it's not present, if not map dot contain, oh sorry, if not map dot contains key, key I have to return. I cannot perform any operation on this. Okay, now what I'll be checking is I have to decrement the count. So int frequency is equal to map dot get key, and then what I'll have to do is if so map dot put frequency key comma frequency minus 1. Then here I'll have to check that if frequency is 0, or let's say so let's just remove it from the map initially. So sorted map dot remove sorry, sorted map dot get frequency, and remove this particular key from the corresponding hash set which is related to the frequency. And then while be using that if sorted map dot get frequency dot is, if it is empty, it becomes empty after removing the key. I have to remove the frequency as well. So sorted map dot remove frequency. Okay, and then I'll be checking that if frequency minus 1 is greater than 0, in this case I'll be updating it then again. So sorted map dot, here it should be not put, here it should be compute if absent. I guess I wrote it wrong over here as well. Compute if absent frequency plus 1 comma sorted mat dot put compute if absent key comma k, a new hash set dot add the particular key. Else this means that it is already present, and then I'll have to do a map dot remove the particular key. Okay, and now let's write the function which are get max key and get min key. So if I'll just do a return if sorted map is empty dot is empty. In this case I'll have to return nothing else. I'll be retrieving the last one. Okay, so sorted map dot last entry dot get value and dot iterator iterator dot next. And similarly I'll have to copy the function for get min key as well. Here instead of last entry it should be first entry. Okay, now let's give it a run. Computer string cannot be converted into an integer. Okay, so frequency plus frequency minus 1. Okay, now let's give it a run again. And it gets accepted. Now let's submit it. And works probably fine as well. Okay, so this was it for today. Thank you for watching.